Hey, scientists may have just found a new planet that looks a lot like Earth, with a big icy catch. This world is about 150 light-years away, rocky, and circles a sun-like star on a schedule pretty close to ours. At first sight, it sounds promising, right? Well, slow down. There's a catch here. It might be insanely cold as Mars in the deep freeze. You see, HD 137010b, that's a mouthful, doesn't seem to be a gas ball, so we would probably be able to stand on its surface. It's a little bigger than Earth and goes around a star that's pretty similar to our Sun. This star is about 146 light-years away from our planet, which, in space terms, is close enough for scientists to study it instead of just, squinting at it. But what made people excited is the fact that this planet takes about 1 Earth year to go around its star. Now that's a big deal, because most exoplanets dash around their stars in days or weeks. Even better, this newly discovered one might sit right on the outer edge of the habitable zone, also called the Goldilocks zone. This region is not too hot and not too cold, which means that liquid water might exist on the planet if it has the right atmosphere. A big if, but still cool. Another thing that makes this planet extra special is how we see it. From Earth, it actually passes in front of its star. Imagine a tiny bug crawling across a flashlight beam. You got it. That makes it way easier for scientists to study things like its size, orbit, and maybe even what its atmosphere is made of. And if all of this checks out, it could be one of the best Earth-like planet candidates we've ever found. And now, the bad news. This planet does not get much sunlight. HD 137010b gets less than 1/3 of the heat and light Earth gets from the Sun. Even though its star is similar to our Sun, it's basically the Sun's quieter, dimmer cousin. Same type, lower wattage. What does that mean for the planet? It could be insanely cold. Scientists think the surface temperature might max out at around minus 90 degrees Fahrenheit. And that's not a grab-a-jacket cold, that's your face freezes right away cold. For comparison, Mars has an average temperature of around minus 85 degrees Fahrenheit. So this planet could actually be colder than Mars, a frozen desert, not to be confused with a frozen dessert, that looks like it gave up on life a long time ago. Another plot twist: this planet isn't officially a planet yet. At the moment, it's still labeled a candidate. Scientists usually confirm planets by watching them pass in front of their star over and over again. Every time that happens, the star dims just a little bit. But with this new space body, we've only seen one transit, a single 10-hour-long mini-eclipse, spotted during Kepler's second mission, called K2. Even with that one pass, astronomers could still learn a lot. They measured how long the planet's shadow took to cross the star, about 10 hours. For comparison, Earth takes about 13 hours to cross the Sun. Then, they plugged that into orbital models and estimated that the planet probably takes about a year to go around its star. That's impressive, but it's still not enough. Astronomers need to see that dip in starlight repeat on schedule to be sure it's really a planet and not some weird stellar wanderer. Unfortunately, this planet orbits far out, and those transits are rare. You don't get one every few days or weeks. You might have to wait a year or more for the next one. That's one of the big reasons Earth-like planets are so hard to find in the first place. So now, scientists are just hoping that other space telescopes can help out. NASA's TESS might catch another transit, or Europe's Cheops telescope could help pin it down. If neither of those catches it, we might have to wait for the next generation of space telescopes to get better data. Because even though this planet sounds like an ice cube in space, it's not totally doomed. If it has a thick atmosphere, especially if it's rich in carbon dioxide, it could trap heat really well, like a planet-sized winter coat. In that case, the planet might actually have a mild climate or even liquid water on its surface. Well, based on computer models, scientists say there's about a 40% chance this distant world sits in the safe, conservative, habitable zone. A chance that is located in a more relaxed, optimistic habitable zone reaches 51%. But there's also a 50-50 chance that the planet is actually outside the habitable zone altogether. In other words, this planet is basically a cosmic coin toss. It could be a frozen wasteland, worse than Mars, a chilly, barely survivable world, or a watery planet hiding under a thick atmosphere. HD 137010b isn't the only place that has the potential to host human civilization in the future. In recent years, astronomers have been spotting new super-Earth planets orbiting remote stars. Now, checking our space vocabulary, super-Earth means a planet beyond the solar system with a mass higher than that of Earth, but below those of the ice giants of the solar system, Uranus and Neptune. One of those planets is Gliese 667cc. It's just 22 light-years from Earth. But even though it seems pretty close, it's still around 129 trillion miles away from us. That's around 1.4 million times the average distance from the Earth to the Sun, so very, very far. The planet itself is around 3.8 times as massive as Earth, and completes one orbit around its host star within 28 days. In other words, a year on that Earth-like planet is 13 times shorter than a year on our planet. Luckily, the star is a cool red dwarf, so the exoplanet most likely lies in its habitable zone. But there's still a chance that this world might be regularly baked by the flares from its parent star. Then there's Kepler-22b. This world is way farther away than the previous world, more like 600 light-years away from our planet. It's larger than Earth and is about 2.5 times our planet's size. Sadly, we still don't know whether this planet is rocky, liquid, or gaseous. The orbit of Kepler-22b is pretty similar to Earth's. It takes the planet 290 days to orbit its G-class star, which is kinda similar to our Sun. But this star is smaller and colder than ours. Now, don't confuse this world with Kepler-69c. It lies a whopping 2,700 light-years away from us and is almost 70% larger than Earth. Researchers know nothing about its composition, but they found out that the planet needs 242 days to complete one orbit. This makes its position in its system similar to that of Venus in our solar system. At the same time, this world might be more hospitable than Venus since its host star is a bit less luminous, 80% of our Sun. As for our Venus, it's an extremely hostile place. You don't want to go there. A runaway greenhouse effect caused by an atmosphere that's about 96% carbon dioxide traps the heat. That pushes surface temperatures up to around 878 degrees Fahrenheit, which is hot enough to melt lead. On top of that, the air pressure is about 90 times stronger than that of Earth, and the whole planet is covered in thick clouds of corrosive sulfuric acid. Oh boy. Compared to our neighbor, TOI 733b seems like a pretty friendly world. This planet was found in 2023. It's floating 245 light-years away from Earth. The coolest thing about this planet is that it might have a massive ocean. According to scientists, this planet is likely to be completely covered with water. Does it mean there could be life on this super-Earth? Well, time will show. And who knows? Maybe soon we'll find even more planets that could become a new home for people looking to explore the universe. As for HD 137010b, the fact that it checks so many Earth-style boxes makes it a really interesting find. It's not a backup Earth yet, but it makes scientists stop and say, okay, this one's worth a closer look, or something similar.
Yes, we have maps, we have math, and we have the laws of physics. We also know how stars burn and how black holes eat light. Let's be honest, we like to think we understand the universe and feel pretty confident about it. And now imagine that all of that is correct and wrong at the same time. There are specific spots in deep space that shouldn't exist. We're talking about places that are too big, too empty, or too powerful for our science to handle. When astronomers look at them, the data doesn't just look weird, it looks broken, like a glitch in a video game. So, forget the standard textbook stuff. Today, we're looking at anomalies. The places where science hits a wall and the mystery begins. So, maybe in the end, we will find out that we do, in fact, live in a multiverse? First, let's talk about speed. We can assume that right now you are sitting still, but you aren't. Earth is moving, the sun is moving. Our entire galaxy, the Milky Way, is rushing through space at over 1.2 million miles per hour. To put that in perspective, at this speed, you could travel from Earth to the Moon in about 10 minutes. It is a velocity that the human brain can barely comprehend. And the scary part isn't the speed, but the destination. We are being dragged toward a specific point in the sky. Something massive is out there, acting like a cosmic vacuum cleaner, pulling thousands of galaxies toward it. Scientists call it the Great Attractor. So, what is it? A super dense black hole? A cluster of dark matter? Are you ready for the truth? We have no idea. The cruel cosmic joke is that we can't even see it. By pure bad luck, the Great Attractor sits in the zone of avoidance. That's a fancy way of saying it's hiding directly behind the center of our own galaxy. The dust and gas of the Milky Way act like a brick wall, blocking our view. Is it only me who thinks that the universe is deliberately keeping a secret from us? Basically, we're like poor sailors on a ship pulled into a fog by a strange force. We know it's there, we can feel its gravity, but we have no idea what this thing is. If the Great Attractor is too heavy, the next place is too empty, and also a bit extreme. The universe usually looks like a spiderweb. Galaxies are everywhere, clustered together. Even the empty space between them usually has a few modest neighbors. But in 1981, astronomers found a patch of sky in the vicinity of constellation Bootes that was just wrong. Too empty, a perfect sphere of nothingness. And it is huge. 330 million light-years across huge. To give you some context, a space this size should contain at least 2,000 galaxies. Do you know how many we found inside? 60. Not 60,000, just 60. It's one of the emptiest places in the known universe. It is so desolate that if our galaxy were in the center of it, we wouldn't have known other galaxies existed until we invented powerful telescopes in the 1960s. We would have looked up and seen nothing but black ink. Not the best scenario for medieval astronomers. Why does this patch of space exist? Standard physics says matter should be spread out evenly. A hole this precise suggests that something cleared it out. Some theories say it's just random. Others whisper about supervoids merging together. But there's always that one creeping thought. It looks artificial, like someone or something cleared the board with a sponge. Now that we have enough room, let's explore the next structure. It's simply too big to exist. Spoiler, it actually does. There is a rule in astronomy called the cosmological principle. It basically says, don't worry, the universe is uniform. Even if you seriously zoom out, everything will still look the same. There are no giant structures. Calculations say that nothing in the universe should be bigger than 1.2 billion light-years across. This limit isn't just a suggestion, it's more like the bedrock of modern astronomy. If things bigger than that limit exist, it means the universe might be lopsided, and physics doesn't allow it. There hasn't been enough time since the Big Bang for anything larger to form. Well, nobody showed those calculations to the giant arc, which was discovered recently. This is a crescent-shaped chain of galaxies that spans 3.3 billion light-years. That's 3 times the theoretical limit. It's enormous. Finding this thing is like walking into a desert where you were told only sand dunes exist and finding a skyscraper. It shouldn't be there. Its existence implies that our fundamental understanding of how gravity and matter work might be flawed. It's a structure that breaks the rules just by being there. Should we go back even further? Maybe to the very beginning. When we look at the heat left over from the Big Bang, the universe is surprisingly even. It's like a warm blanket with the exact same temperature everywhere, except for one spot. In the southern sky, there's a massive bruise, a region that is significantly colder than everything around it. It's also huge. We're talking about 1 billion light-years wide. The odds of this happening by chance are less than 1%. It's a statistical impossibility. Of course, scientists tried to explain it away. Maybe it's an instrument error. Nope. Multiple satellites confirmed it. Maybe it's a supervoid pulling energy out of light. Maybe. But there is a more radical theory gaining traction, one that sounds like science fiction. Some physicists suggest this cold spot is a collision mark. Imagine that our universe is just one massive bubble floating in a sea of other bubbles. Yes, we're talking about a multiverse. If our bubble bumped into another universe billions of years ago, it might have left a scar. Think of it like soap bubbles in a kitchen sink. When two bubbles touch, they flatten against each other. That flattened wall is exactly what we might be seeing right now. A boundary where our reality literally touched another dimension. If that's true, we aren't looking at a random anomaly. We are looking at the first physical proof that we are not alone in this reality. And finally, the most disturbing mystery of them all. We've already talked about the great attractor pulling on our galaxy, but recently, researchers have noticed something much bigger. They've realized that huge clusters of galaxies, and we're talking about hundreds of millions of light years apart, are all drifting in the same direction. It's like a cosmic river flowing toward a patch of sky between Centaurus and Vela. They call it the dark flow. But according to science, the universe is supposed to be expanding in all directions. There shouldn't be any flow. And even worse, there's nothing in our observable universe massive enough to cause this movement. We checked. The visible universe ends about 46 billion light years away, and there is no object big enough to affect all these galaxies. So, what is pulling us? The only logical conclusion is terrifying. Whatever is dragging these galaxies is located outside our observable universe. It's a structure of unimaginable size, sitting just beyond the edge of the map. We know it's there because we can measure its gravity, but its light will never reach us. It is a monster in the dark, forever out of reach, slowly reeling in parts of our cosmos. These places serve as a humble reminder. We have mapped the continents, but we have barely dipped our toes into the cosmic ocean. The universe is full of ghosts, broken laws of physics, and things that make our galaxy look like a speck of dust. Please remember to keep looking up, even if you don't always understand what you see.
Here's our home, good old Earth. Let's zoom out, way, way out, until we're roughly 100,000 light years away. Okay, from here, it's possible to see our entire galaxy, the Milky Way. It looks like a huge shining disk in the dark. But new models suggest that what we can't see is that this bright disk is actually floating inside a giant pancake made of the mysterious dark matter. Ooh, pancakes. I'm getting hungry. Want to learn more? Well, follow me. The Milky Way is like a colossal spinning pinwheel in space. If you step outside on a clear night and get away from city lights, you'll see a bright milky band stretching across the sky. That glowing stripe is our galaxy, and we're looking at it from the inside. We're positioned on one of the outer arms, gazing toward the bright packed center. Our galaxy has close to 400 billion stars, and our sun is just one ordinary star floating in that huge crowd. Yet, on a universal scale, our massive home is basically a single grain of sand on an endless beach. The observable universe spans over 93 billion light years across. It holds billions of other galaxies. That's so many zeros, it's worth talking about them. So let's zoom back in. What does it mean to be sitting on a giant flat slab of dark matter? Well, regular matter creates everything we can actually look at. It builds glowing stars. It forms rocky planets. It even makes up your own body. Regular matter interacts with light, so our telescopes can measure it. Dark matter is the opposite. It is invisible. It does not reflect light. And as far as we can tell, it doesn't interact with light in any direct way. Scientists know that this hidden material exists because of what gravity gives away. The Milky Way spins at roughly 130 miles per second. At that speed, the outer stars should literally fling right off into empty space. They should fly away like water droplets spinning off a wet tennis ball. The gravity provided by all the visible stars is simply not strong enough to keep the galaxy intact. There has to be far more unseen mass creating extra gravity. That hidden mass is dark matter. It accounts for about 85% of all the material in the universe. It acts like an invisible skeleton keeping galaxies together. Without it, the Milky Way would rip itself apart. But dark matter is usually imagined as a giant round halo around a galaxy, almost like an invisible cocoon. This recent study suggests that on a much bigger scale, the Milky Way is sitting inside a broad dark sheet, something more like a pancake than a ball. Our region has 3 clues. Nearby galaxies form a flat structure. Huge voids sit next to it, and the local expansion looks oddly tidy. The study says those may all be parts of the same bigger shape. According to the model, the Milky Way and its neighbors may sit inside a much larger pancake-shaped concentration of dark matter stretching tens of millions of light-years, more like a broad, spread-out slab of invisible mass. That hidden mass could shape the whole neighborhood. It could help pull galaxies into a flatter arrangement instead of letting them spread more evenly in every direction. It could also help create emptier regions above and below that layer. It may even explain the smooth motion. If nearby galaxies are moving inside a much larger structure, then their paths are being guided by that structure. The quiet Hubble flow may not be a coincidence. It may be a clue. Now, astronomers did not see this dark sheet directly. They worked backward from motion. They measured where nearby galaxies are and how they move, then asked what kind of hidden mass would produce that pattern. The answer was not a blob, not a sphere, not a random cloud. It was a flattened structure on an enormous scale. So, how do you find a giant invisible structure you can't see at all? Well, you look at what it does. Scientists tracked how isolated galaxies near us are moving and use them like bright markers in the dark, revealing how unseen gravity is tugging on them. Then they ran simulations to test what kind of hidden structure could create that pattern. A big, invisible sphere did not fit very well because gravity from a round cloud would pull things inward more evenly. A broad, flat shape matched the observations far better. This flat structure reshapes how we explain our part of the universe. It acts like a huge invisible tabletop where galaxies tend to line up. Because of this, the space right above and below is empty. It explains why we have these giant uninhabited zones of space nearby. This pancake is like a hidden framework that keeps our corner of the universe organized. And this hidden structure does not just shape where galaxies sit. It may also be moving as part of a larger cosmic flow. The entire dark matter pancake is hurtling through space. We are surfing on a cosmic wave through space at a ridiculous speed. The whole flat sheet is being dragged toward a dense region of space astronomers call the Great Attractor. It is the gravitational anchor of our local universe. Basically, it's a dense, packed region containing tens of thousands of other galaxies grouped closely together. All those galaxies combined create an immense amount of mass. That weight generates a gravitational pull so intense it bends the fabric of space. It forces everything within hundreds of millions of light-years to fall toward it. It acts like the low point in a giant cosmic landscape, pulling our entire dark matter pancake with it. The wild part is that we still can't see this structure. The Great Attractor hides behind a thick glowing band of stars at the center of the Milky Way. Astronomers call this blocked area the Zone of Avoidance. Ooh, good nickname. Trying to look at it is like trying to admire a mountain through a completely mud-splattered car windshield. We know a massive cluster of galaxies is pulling us, but the dust and gas of our own galaxy block the view. Our dark matter pancake is actually just a tiny crumb inside a much larger structure. We belong to a colossal cosmic continent called Laniakea. That word means immense heaven in Hawaiian. It stretches 520 million light-years wide. It contains the weight of 100 million billion suns. The great attractor is the gravitational heart of this supercluster. Our flat neighborhood is sliding down a giant invisible funnel toward that center. The quiet Hubble flow keeps most of our distant neighbors drifting away peacefully. But there was supposed to be one major exception: the Milky Way crashing head-on into Andromeda. For years, that future collision sounded almost guaranteed, a huge galactic wreck. Stars flung around, two giant spirals blending into one monster galaxy. Except now, that prediction looks a lot shakier. Newer studies suggest the odds of a crash in the next 5 billion years are actually tiny, and even over 10 billion years, it is closer to a coin toss. So the universe may be canceling one of its biggest predicted disasters. So the discovery of this invisible flapjack changes how we look at the night sky. We used to believe glowing stars told the whole story. Now we know they are merely the sprinkles on top of an invisible pancake. The real architecture of the universe is mostly hidden from our eyes. Now, if all this talk about pancakes made you hungry, me too, here's a fun bit of trivia for the end. The famous Milky Way chocolate bar was not actually named after our galaxy. The creators named it after a hugely popular malted milkshake from the 1920s. They wanted to capture the exact flavor of a sweet diner drink in a solid candy block. But that's not the only coincidence. The company producing the Milky Way is called Mars. That title has absolutely zero connection to the red planet next door. It was simply the last name of the company's founder, Frank Mars. Since we now know our huge galactic home rests right on top of an invisible pancake, let's hope somebody actually gets inspired to invent a pancake dessert. Saturn's rings. Impressive, right? But look closer. They're crooked. Actually, the whole planet is tilted by nearly 27 degrees, which is way more than it should be. Look at its neighbor, Jupiter, for example. It has a tilt of only 3 degrees. So, what happened to the Lord of the Rings? A new study suggests that Saturn used to have a huge extra moon. Yeah, besides the other 274 it currently has. But who's counting? Millions of years ago, that space rock might have crashed straight into Saturn's largest moon, Titan. The collision was so massive that it could have knocked the planet off balance, leaving it even more tilted than before. This extra moon hypothesis is a pretty good one, but to fully understand it, we first need to look at previous theories on why Saturn is tilted in such a strange way. Theory number 1. Blame it on Neptune. Poor guy, this planet is about 1.8 billion miles away, but he ended up becoming the main suspect. For years, astronomers believed Neptune's gravity slowly pulled Saturn over onto its side over billions of years. They thought the two planets were locked in something called orbital resonance that happens when two moons or planets sync up and start pulling on each other in a regular rhythm. Well, here's the thing. A planet's orbit is massive and carries a huge amount of energy, while the way a planet spins is much weaker. So, when you lock these two motions together, Neptune's orbit and Saturn's spin, it's Saturn's spin that's going to change and end up tilting. That's the power of orbital resonance. But then, Cassini happened. Back in 1997, NASA launched this spacecraft to explore Saturn and its icy moons. Cassini stayed out there for 13 years, and it shared some really interesting discoveries, including the fact that, nope, Neptune is not our guy. Cassini's data showed that the two planets aren't exactly in sync. So that couldn't explain Saturn's crooked posture. Something was missing. But what? That leads us to theory number 2. It's Titan's fault. Poor guy, he was just there, hanging out as Saturn's largest moon, when suddenly he became suspect number 2. Okay, to be fair, it's more like Titan is the leader of the gang, but the other moons are helping out too. 2 scientists from France came up with this theory in 2021. Back then, we already knew that Titan and the other moons were moving away from Saturn. But their observations showed this is actually happening much faster than we thought, at a rate of about 4 inches per year. Yeah, really. Eventually, Titan could even be kicked away from Saturn's orbit entirely. And this whole process actually messes with the way Saturn leans. As the moons drift further away, the planet just tilts more and more. This explains why Saturn is still actively leaning today. In fact, over the next few billion years, the planet's tilt could more than double. Well, that's all pretty interesting, but it doesn't explain one big mystery. Saturn wasn't always that crooked. Some scientists believe that for over 3 billion years after the planet first formed, its lean was actually pretty small. So, something must have happened to change all that. Something big. That's how we got to theory number 3. It's Chrysalis's fault. And again, poor guy, this hypothetical moon might not have even existed, and we're already blaming it. Back in 2022, scientists came up with an idea about a lost moon called Chrysalis that vanished about 160 million years ago. This theory says Chrysalis orbited Saturn for billions of years, helping keep the planet in sync with Neptune. But then, things took a turn. As the moon spiraled inward, Saturn's massive gravity didn't just pull it in, it literally ripped the moon to shreds. Losing Chrysalis's weight and its gravitational pull was like a cosmic kick. It broke Saturn's old connection with Neptune and knocked the whole planet over on its side. In other words, its disappearance could be the reason why those two planets aren't perfectly aligned anymore. Now, even though the moon's solid body is gone for good, its remains didn't just vanish. They flattened into one of the stunning rings we see today. I mean, the exact same thing that tilted the planet also gave it its most famous feature. So, basically, Saturn's famous ring system used to be a moon. Well, how cool is that? Anyway, scientists decided to test this out. But when they recently ran some simulations to see exactly how it all happened, they found a problem. In most of those versions, Chrysalis didn't actually hit Saturn. Instead, it crashed into the megamoon Titan and merged with it. But Titan wasn't Titan back then. There might have been an earlier version of Titan that was a lot more massive than Chrysalis was theorized to be, about 4 times as big. Here's what the team thinks really happened. If we go back 400 million years, Saturn looked completely different than it does now. There were no rings, and it had a different set of moons than the ones we see today. Back then, 2 of them were huge. Let's just call them Moon A and Moon B. At some point, Moon A's orbit shifted and got locked into what's called a 2-to-1 resonance with Moon B. Basically, that means for every one time Moon B went around Saturn, Moon A went around twice. That rhythm caused Moon A to start moving inward pretty fast. Eventually, the inevitable happened. They slammed into each other. That collision ended up doing 2 main things. First, Moon A was pretty much destroyed. A huge chunk of it crashed onto the surface of Moon B, while the rest turned into a giant cloud of debris. Eventually, all those leftover pieces clumped back together into one piece, which became the current moon, Hyperion. The theory actually explains why Hyperion isn't a perfect sphere. It's shaped more like a potato. As for the rest of it, the part of Moon A that hit Moon B merged right into it. Together, they formed the version of Titan we know today, a massive icy moon that's bigger than the planet Mercury. Now, this merging process might also be what created Saturn's rings, maybe about 100 million years ago. As Titan's orbit expanded, it messed with some of Saturn's inner moons, shaking them up until they eventually smashed into each other. Some of that leftover debris stayed behind and became the rings we see today. But we can't say for sure if that's exactly how it went down, mostly because we still don't know how old Saturn's rings really are. So not every scientist is totally sold on this theory yet. Take NASA researcher Linda Spilker, for example. She says this study makes a really strong case that Hyperion and Saturn's rings actually showed up long after the planet itself was born. But the truth is, the rings could be much older than that. And if that's the case, the timing for this theory really doesn't line up. That means we'll have to wait for more proof before we can say for sure. But the answer might be coming soon, thanks to NASA's $3 billion Dragonfly mission. And the whole idea is to explore Titan up close. This is a spacecraft about the size of a Mini Cooper that works a lot like a high-tech drone with 8 rotors. It's scheduled to launch in 2028 and should arrive at Titan by late 2034. Once it gets there, it's going to spend about 2.5 years exploring different spots all over the moon. Since it has propellers and landing skids, it won't be driving on the ground like a rover on Mars. Instead, Dragonfly will travel by air. It'll take off vertically, fly to a new location, and land again. basically hopping across the moon. The mission might finally give us the answers we need. Dragonfly could test this theory by looking for geological or chemical signs of a huge crash between two moons a long time ago. And if it finds them, bingo! One of Saturn's greatest mysteries will finally be solved.